Okay, so I look at where this has a max or a min, and I know that's going to create an x-intercept for my second derivative. Okay, the left side of the graph is increasing up to that maximum, up to right here. So that means my second derivative needs to be above the x-axis because it needs to be positive. So I know I've got that going on. In between the max and the min, it is decreasing. So my second derivative would need to be below the x-axis. And then after that minimum, it's increasing, so that would need to be above the x-axis. So let's pause there for a second. How do we do on the second derivative? Okay with that? And it should make sense. The red graph, that's clearly a cubic graph. My derivative of that will be a quadratic. What will the original be? Quartic, yeah, fourth degree. So let's try to work our way back to that one. So the way we find that original graph, where the red graph has x-intercepts, that's where I have either maximums or minimums on the original graph. So if I look at this first one on the left, the red graph is below the x-axis. So what does that mean the original graph was doing? Decreasing, okay? So am I going to have a max or a minimum there? A minimum, okay? So I'm going to have something, we'll just say it's going to be down here. It's definitely decreasing to that point. The second blue dot x-intercept I have, is that going to be a maximum or a minimum? Maximum, yeah, because the red graph is above the x-axis, so it must be increasing up to that. Your third blue dot at the end there, is that going to be a max or a min? Because the red graph was below, so it's got to decrease. I almost made it there. And then what's going to happen after that dot? It's going to increase. Okay. Right. So that is what your original should have looked like. Now, you know, it's not perfect with how high any of these are going. We aren't calculating any numbers, but just the general idea of increasing, decreasing, max and min. And you can double check with the concavity, all of that. It's pretty close on my green dots with that. So. Do we feel a little better about that than we did with the second example in the notes the other day? Okay, we'll keep working on it. Any questions before we jump into the notes? Yeah.
Is there any like significance with the stuff with the original x and the second derivative?
So not really. All that's happening is this right here should be where the inflection point is, since that it didn't line up perfectly, since that's where the 0 is, the x-intercept of the green graph, the second derivative. Yeah, it's not that the x-intercept of the blue graph matters, it's the point of inflection that matters. Okay. I just kind of drew it where they ended up being on the x-axis. Other questions, guys? Okay, before we start notes, let me just talk quickly about the end of the year for you guys. I don't think I gave you guys an assignment sheet last time. Okay, today we're doing implicit differentiation, and we just have trig derivatives left, a review day, and a test day, so just normal going through a unit. Then after that, you'll have a review day if you're doing either retake. Then we'll have the retake day. No school for you guys on June 1st because of graduation. So that week of May 30th, Monday you don't have school because it's Memorial Day. Tuesday's a black day. Wednesday no school because of graduation. Thursday's a black day. I only see you on Friday of that week. Okay, it's kind of a weird week. What we're gonna do on that Friday is have a cumulative review day of all the units 1 through 11. And then your last day, other than the plaid day at the end of the year, is the 7th. And you guys will have an optional, it's not a final, but it kind of is a final, an optional cumulative test. And the grade on that test can replace your lowest test grade of the year. Okay, so it's kind of like one final retake for whatever test you didn't do so great on. It won't hurt you, it can only help you. But again, it's optional on that day as well. Those are your half days that week where you only come in for 2 periods. So does anybody have questions about the end of the year or any of that stuff? Yeah.
Is Unit 11 going to be all math-based?
No, it's probably going to be a combo. Other questions? In Unit 11, the test is tough just because it's combining everything from Unit 10 and building onto that. So you have to know it well. And the optional cumulative test at the end, it'll be about 50 questions long because it'll be 4 or 5 questions from each unit throughout the year. And I won't pick like the 4 or 5 worst questions, but it's hard just because it's 11 units worth of material. What, Robert?
So how long will we get to finish all of these questions?
You 1 class period. It is multiple choice though, which helps.
Like the whole multiple choice?
Yes.
Oh.
So cool. Otherwise, there's no way I'd get the grading turned around because your grades are due the next morning at 8 a.m. So it wouldn't be realistic for me to grade 50 free response questions for you guys. So yeah, it's all multiple choice. Other questions? Okay. Oh yeah.
So you're gonna have a review like the day before?
The day before will just be like a workday review, look through your notes, look through. And again, the questions aren't like super tricky, but it is just a lot of material. Like right now, if I was like, solve a law of sines problem, do you remember? You know, so it's going to take you some time to prep for it. Okay. Okay, time for implicit differentiation. So 11-2, your second to last set of notes, guys. Okay. So far, if I gave you something like y equals x squared plus 5, and I said find dy dx, would you know what I was asking for? Yeah, derivative of y in terms of x. So what would you tell me the answer to that is? Okay. What you're really doing that you haven't sort of seen, say I start like this, and I ask you for dy dx, you are absolutely using that power rule of 2x, but you've been multiplying this by dx dx. We just never write it because what do you think that is? Yeah, it's not going to change the value of anything. We're going to have to do something similar to that with implicit. So it's been there all along. You just haven't had to write it because it's been derivative of x in terms of x, which is just 1. So let me show you what I'm talking about with our first one. So we're going to find dy dx. And my equation is y cubed equals x squared plus 5x. So what do you see that's different here? Y cubed, right? It's not just a nice y equals. Now, could you take the cubed root, solve for y, do some things like that? Yes, that's not what I want you to do. Not every equation will lend itself to that in any sort of clean manner. So we're going to do this with implicit differentiation. So we're going to use a lot of what you already know as far as power, product quotient, all of those rules. So what would you think the derivative of y cubed is going to be? 3y squared. Okay, excellent start. What you have to put with this is dy dx. Anytime you take the derivative of a y term, you have to say times dy dx, because we're taking the derivative of y in terms of x. Now, what do you think is going to be on the other side of this equal sign? 2x plus 5. You could write 2x dx dx plus 5 dx dx, but we still don't need those dx dx's, okay? So 2x plus 5, nothing has changed there. What are we solving for? What did I ask you to find? dy dx. So let's solve for dy dx. What would that be equal to? 2x plus 5 divided by 3y squared. Yes. That is your answer. So you're going to have y's in places that you're not used to having y's. It's really the big difference with implicit. Questions on the first one? The hard part is that it's just really easy to miss a dy dx. When we get into equations that have lots of y's in them, you have to remember to do it every single time. But otherwise, your power, product, quotient, all of those rules are exactly the same. Let's try again. All right, let's say this time we have y cubed minus 2y plus x cubed equals x squared plus 2. Okay, let's try this one together. So y cubed, what am I going to write for the derivative of that term? Yes, 3y squared dy dx. Excellent. Minus, what's going to come next? Yes, 2 dy dx. We're taking the derivative of y in terms of x. So 2 dy dx. Plus, what's next? 3x squared, good. Equals, okay. So at this point, that's all the new stuff. Everything from this step on is algebra, okay? What are we solving for? Okay, so I want to keep those terms on one side, so I'm going to rewrite it. We'll get to a point where you can kind of skip some steps, but I want to make sure I show you everything right now. So 3y squared dy dx minus 2 dy dx equals, I'm going to say negative 3x squared plus 2x. What can I factor out on the left? dy dx. Handy, that's what we're solving for. So I'll have 3y squared minus 2 left in parentheses. So what is dy dx going to equal?
3x squared plus 2x all over 3y squared.
Yeah. How do we feel about it so far? Not too bad? Okay. Let's try again. All right, find the slope of the tangent line at root 2 comma negative 1 over root 2 for x squared plus 4y squared equals 4. When you see slope of the tangent line, what should you think of? Find the derivative, right? Okay. Do you have to use the limit definition of the derivative? Or can I use the shortcuts? I can just use the normal power product, implicit, all of that, okay? Again, people on your test, when I said find the derivative, you went the long way with the limit definition. Do not do that to yourselves, okay? Especially with implicit, that would be a mess. So we're just going to find dy dx. I want you guys to try to find dy dx on this one. I'll give you a few minutes. And then we'll go through how to find the actual slope at that point. So you guys do the dy dx part. All right, guys, let's go through it and see how your dy dx went. So if I'm finding the derivative here, I would do 2x. And then I'd say plus 8y dy dx. And what's it going to equal on the other side, guys? 0. Yeah, derivative of 4 is 0. So I've got 8y dy dx plus negative 2x. So when I divide, are you guys okay with me going to negative x over 4y? We do okay there? Okay. that's the formula to find the slope at any point along this curve. I've told you I want it found at root 2, comma, negative 1 over root 2. So what do you think I'm going to do with that? Plug it in. Yes. So slope is going to equal negative root 2 over 4 times negative 1 over root 2. Okay, so let's simplify that. So you've got negative root 2 divided by negative 4 over root 2. What can I do when I'm dividing by a fraction? Yep. So this is really negative root 2 times root 2 over negative 4. What's negative root 2 times root 2? Negative 2, or 2 if you deal with the negatives. 2 over 4, are we okay with that? What do we end up with then? Okay. So that is your slope of the tangent line at that point. Okay? Sure. Is that far enough, or you want all the way to the... That's good? Okay. You just missed part of the point.
I wrote down negative, or I wrote down positive.
Okay.
So I got negative 1.
Easy mistake. All right. Let's keep going, guys. Okay. I know it looks like the 2's are in weird places. That's where they go with this notation. What am I asking you for with that? Second derivative, okay. And your equation is negative xy equals x minus y. We're going to do this one together, okay? If I'm asking you for the second derivative, what do I have to find first? First derivative. Matthew, will you put your phone up front, please? Just put it in the holder. Thank you. Maybe. Okay. Good job. All right, we need to find the first derivative. Do you see anything different in this equation for how we're going to have to find the first derivative? Anybody notice anything? We've used just the power rule the whole time, right? Is there a different rule we might have to use here? Product rule, right? You guys see that it's x times y? You have to use the product rule. Okay? So I'm going to do, you've got these two terms, like this is what you're looking at, negative x times y, okay? So I'm going to say y times the derivative of negative x. So what's the derivative of negative x? Okay, negative 1. Plus negative x times the derivative of y. So what am I going to write there? Yeah, 1 dy dx. So you can write the 1 if you want. Definitely need the dy dx. Okay, over on the right side, they're not multiplied. You can just use the power rule, all the stuff you've been doing so far. So what's the derivative of x? 1 minus what's the derivative of y? Okay. We okay with that so far? All right. We're solving for dy dx. We want all the dy dx's on one side, everything without a dy dx on the other side. So I'm going to bring this minus dy dx over. So I'll have a positive dy dx minus x dy dx. And then on the right side, I'll have 1 plus y. Just moved things around there, okay? What am I going to factor out on the left? Okay, dy dx, and that'll leave me with 1 minus x. So I know dy dx is equal to 1 plus y over 1 minus x. Stop there for a second. We are going to need this later. We obviously have to still find the second derivative, but we're going to need that, what that equals later. So far, so good, though, right? Okay, so second derivative. So notation here. Nothing extra to do on that left side. That's just taking the second derivative. What do you think we're going to have to do on the right side? Quotient rule. Yep. So the denominator, 1 minus x, times the derivative of the numerator. Well, what is the derivative of the numerator? Just dy dx, right? You guys see it? Okay. Minus numerator, 1 plus y, times the derivative of the denominator. Well, what's that derivative? -1. All over that denominator, 1 minus x. Lost my 1. Yeah, quantity squared. Okay, let me move that up just a little. Are we okay there? You're essentially done with the calculus stuff, and now it is all algebra skills. I don't want a dy dx in my answer on the right-hand side. What do you think I should do? Don't need to divide yet. Do I know what dy dx is equal to? Right? Isn't that what I put in a little squiggly, bubbly thing there? So in place of the dy dx, I'm going to write 1 plus y over 1 minus x. So we just have a whole bunch of simplifying ahead of us. So I now have 1 minus x times 1 plus y over 1 minus x. And then I'm going to go ahead and distribute and deal with the negatives over here. Negative times -1. Do you guys see that would just be plus 1 plus y? Okay, there. And then still all over 1 minus x squared. Okay, what happens? Yeah, guys, these cancel. This 1 minus x, you can think of it as being over 1, is going to cancel with the denominator of the fraction it's being multiplied by. You can cancel a numerator and denominator with fractions when you're multiplying, as long as it's an entire factor. So my final answer here for the second derivative, what do I actually have left in the numerator? 2 plus 2y. Yeah, if I combine my like terms, over 1 minus x quantity squared, and then you're done. Questions? It's not really hard. It's just lots of little pieces everywhere. Don't mess up a sign. Don't forget to substitute. Don't forget a dy dx. All right, we just have one more example, okay? So stop me if you have questions. All right, let's do... What is the slope of the tangent line to xy plus 2x y cubed equals 6 at the point 2, 1. Okay, you guys are going to try this one on your own. Do you see product rule twice here? Okay. So it's x times y, 2x times y cubed. Okay. All right, so I'll give you a few minutes here.
Product rule. Equal to 6.
Check in with each other, see if you got the same slope. You should get just like a number at the end here. Seeing some looks that are like, oh. Hush. Hush. I'll put the slope answer up here, see if you guys got it. Only look when you're ready. Yay! Always such a nice feeling when you're like. Right, like that's not a number that makes you feel good about things. Yeah, we were talking about that with the AP exam that just happened with calculus. We were looking at some of the free response, and it's like one of them, it was just like ugly fractions the whole way through, and you just doubt yourself when you're, you're like, this feels wrong. So, yeah. Okay. All right, all right. Baby steps, right? I'll go through all of it. Don't worry. I just want to give you a chance. See if you got it. Did you get it, Jacob?
I got a positive 2.
Oh, interesting. Okay.
Minus 4 sevens.
Okay.
-3/18.
It's 3/18. All right.
If you're 50.
You're so close.
That's why I need some.
Yay!
I know, I just made a mathematical.
You just can't plug stuff in.
Yep.
Yeah, I know.
I had 3 and 2.
It happens sometimes. You'll be fine with the calculus stuff in calculus. It's the algebra stuff that you're like, ah. All right, guys, I'm going to start going through this. Derivative, you've got to use product rule twice.
What? 3y squared.
That's what I thought.
I think 2x plus y cubed. And that turns into.
Oh my god, yeah. I just wrote it. I just can't read it. I have issues. Yeah. It's like so short.
All right, let's make sure we're okay with the actual derivative. Negative 2y cubed minus y over x plus 6xy squared. Let's look at that, see if anything went wrong there.
Do we do any more practice questions after this?
Nope, last one and then I. Yeah, go ahead. Question?
Yeah, I did it. I just can't.
You just can't plug in numbers? You know. All right, I'm going to go ahead and plug in the numbers. So I've got negative 2 times 1 cubed minus 1 over 2 plus 6 times 2 times 1 squared. So that's negative 2 minus 1, negative 3. 2 plus 12 is 14. That's it, guys. Okay? Questions? Was it just little things that threw you off on that one if you got it wrong? Oh, yeah, question, Kristen? Oh, yeah, I just multiplied this term. I did the 2x times 3y squared. So I saw both of these had dy dx in it, so I factored that out. X and then multiplied those. And then I moved all the other stuff over. All right, guys, questions? Okay, let's do our quizzes.
Yeah.